Good afternoon. In this lecture, we are going to learn about the image enhancement. Now, what is meant by image enhancement? It is the process of manipulating the image to give the results which is more suitable than original, and it is more specific for specific application. For example, the technique which is used for the enhancement of X-ray images may not be best one for the microscopic images. Hence, we can say that the enhancement algorithms are highly subjective. We can broadly classify image enhancement techniques in two categories, spatial domain and frequency domain. Now, spatial domain techniques, they works on the image plane itself. That means there is a direct manipulation of image pixels. Whereas frequency domain techniques, they modify the Fourier transform coefficients of an image. And after that, we can take the inverse Fourier transform of the modified coefficient to obtain the enhanced images. But what is meant by good image? For human visual, the visual evaluation of image quality is highly subjective process, and it is hard to standardize the definition of good image. But for machine perception, the evaluation task is easier. The good image is one which gives the best machine recognition result. So before choosing a particular image enhancement method for a certain application, some amount of trial and error is required. Now, spatial domain enhancement technique. Now we already know the term spatial domain refers to the aggregate of pixels composing of an image. So we can say spatial domain process can be denoted by g of xy is equal to some transfer function applied on the input image f of xy. Whereas this f of xy is the input image, g of xy is the process image, and t is an operator which is defined over some neighborhood of xy. The operator can apply to a single image or a set of images. This figure shows the basic implementation of the above equations. The point is an arbitrary location in the image, and small region containing the points is a neighborhood of the xy. Typically, the neighborhood is a rectangular centered on xy and much smaller in size than the image. Now, if suppose the operations which you are applying onto the image is having the neighborhood of size 1 by 1, that is the single pixel, then that processing is called as point processing. And in this case, the G will depend on the value of f at xy only. So T becomes a gray level, or also called as the intensity or mapping transformation function of the form, which will have S is equal to T of R, where R is the gray level of input image and S is the gray level of output image. Now, what are the basic intensity transformation functions available which will give the enhanced result as compared to the original regions? We can classify them as linear function, logarithmic function, power law functions, and piecewise linear transformation functions. Under this category, again, we are having contrast stretching, intensity slicing, and bit plane slicing. So let us go for the basic gray level transformation functions. Under the basic intensity transformation functions, as we told earlier, we are having linear functions. Under this category, we are having identity function and negative function, logarithmic, log and inverse, and under power law, nth power and nth root transfer functions. So in the next lecture, we'll see how these transfer functions can be applied to get the good